One API request, one order, two payment charges. And the scary part, your application didn't throw a single error. It wasn't a payment bug, it wasn't a database bug, it was an event-driven architecture bug. You see, in a system like this, services don't call each other directly. An order gets created, it fires an event, and other parts of the system, like the inventory, payments, notification, react to that on their own, independently. That's the whole appeal, decoupled, scalable, resilient, until a listener retries a crash with no idea it ran once. So you do not have any stack trace, no 500 error code, no alert, just a quiet duplicate charge and an angry customer. In the next few hours, we are going to build the exact system that prevents this. From an empty NestJS project, event emitter 2, BullMQ, Redis, idempotency keys, death letter queues, correlation IDs, real production architecture, and not just a toy example. And by the end of this, you're not just going to know what BullMQ is. You're going to understand exactly how senior engineers build systems that do not lose money when something goes wrong. You're also going to learn retries that do not duplicate. Also, how to handle errors that don't just disappear out of your system, and events that you can actually trace from end to end. This is the stuff that separates developers who can follow a tutorial from developers who can actually architect real-world systems. Let's go on and master event-driven architecture. Okay, so we have an empty folder, nothing yet exists. Let's go on and fix that. I'm going to make use of the NestJS CLI to scaffold the project. So the command is sudo npm install -g at nestjs/CLI, which we need to create a new NestJS project. The CLI has been installed for me. Now I'm going to generate a new NestJS project making use of the CLI, and this is not the interesting part of the video, so I'm going to move through this pretty much fast. But I want you to see this happen for you because I'm not going to be skipping a single step in this build. So next new NestJS event-driven orders, the name of our application. I'm going to go with npm as the package manager of choice, and this is going to give us a full working NestJS application out of the box. So let's wait for the installation to complete. And now the installation is completed, the next step is to cd into the created application. So I'm going to say nest or cd NestJS event-driven orders, the name of the application, and then you can open it with Visual Studio Code or any code editor of your choice. Now we are here. This gives us a full working NestJS application. So we have a controller, a service, a root module, and we also have a main.ts bootstrap file over here. And if we run this on port 3000, we're going to get the classic hello world. So let's start up the NestJS application. I'm going to say nest run start dev, which is the command to start up your new NestJS application. Now, as I said, we're going to get our classic hello world. So if you check out the app controller, you see this is a get request that calls the app service, and the app service returns hello world. Now what this means, if we open up our browser and go over to localhost port 3000, we see the classic hello world over here. Cool, so this is what we get by default, and at this point the application knows nothing about orders, events, or queues, and this is exactly the starting point we need, and we're going to build everything from the ground up making use of this file. Before I write a single feature, I'm going to install everything that the entire tutorial is going to need, and I'm actually doing this on purpose. I might miss one or two along the line, but if I do, then I run the installation. But the idea is to have everything installed at a go so that we can just focus on what we are building. Now we're going to have 4 installs: the NestJS event emitter, and also the BullMQ and the NestJS packages. So let's not waste any more time. Let's go into installing the different packages that we need. I'm going to start up by stopping the server and also clearing this. And let's start with the event emitter. So I'm going to say npm install at nestjs/event-emitter package. This is going to give us in-process events, which is what we're going to use for the first version of our system. So let's wait for the installation to complete. And once this is done, we're going to install the second package. Now the second package we're going to install, I'll say npm install at nestjs/bullmq. We also need to install BullMQ package and also IO Redis package, and this is going to be our durable queue stack. BullMQ is going to talk to Redis, and IO Redis is the Redis client underneath it, and we also need the NestJS BullMQ package, which is going to just give us the NestJS flavored package with decorators and stuff like that. Now we're going to install the third, which is the class validator and also class transformer. So npm install class validator and also class-transformer. And this is how we are going to go on to validate our incoming request bodies with proper DTOs rather than having manual if checks around the code base. So we're going to wait for this installation to complete, and then we're going to install the last package. The last one is going to be npm install, and that is at nestjs/config. Now this is needed so that our Redis connection detail is going to live in our .env file instead of hard coding everything in our code base. And once you have all of these installed, the next step is for us to create the .env file. So we're going to be creating this .env file at the root of the application. And in here, we're going to have the port, which is going to be 3000. We're also going to have the Redis_host, and this is going to be equal to localhost. And lastly, we're going to have the Redis_port, and the Redis_port is going to be equal to 6379. So let's go ahead and have this here. And now you just want to double check that you have this in the .gitignore, because you don't want to push this over to GitHub. So make sure you have the environment variables here. Small habits like this is going to save you from accidentally committing your different commits. And that's pretty much it for everything we have here. Now that we have this here, the dependencies are in, we are going to go on and lay out the folder structure, which is going to mirror how our system is actually going to be organized before we go on to write a single line of business logic inside it. Okay, before I go on to write a single controller or service file, I want to go on and lay out the different folders that we are going to need. So we're going to need 5 folders: order, inventory, payments, notification, and also audit. So we're going to go on to establish the domain-oriented folder structure. We are going to be doing this inside the src folder. So we need to cd inside the src folder, the source folder, which is this folder over here. And here we're going to create the different folders. So I would make use of the terminal, and I'll make the directory here, which I would start with the orders here. So now we have the orders. I'm going to do the same for inventory like this. And the next is going to be the payment folder. So you see it over there, or you can create it manually. And after payments, I'm going to create 2 more, one for notifications. And then I'm going to make a new directory for audit. Now we have all these 5 folders created, and over here, every one of these is going to become its own NestJS module. Every one of them except the orders, which is going to go on to react to events instead of being called directly. Now the orders isn't going to know that the inventory folder exists, and the inventory isn't going to know that the payment module or the payment system exists. So that isolation is the whole point of event-driven architecture, and I want the folder structure to go on and make that obvious before we go on to write a single import. And then we are going to be creating the common folder, things like interceptors, filters, decorators. This is where cross-cutting stuff is going to be inside the common folder. And we're going to also have the event, the global listener handler, which we're going to set up in a later video, and also the correlation ID interceptor, which we're also going to go on and create in later video. So nothing domain specific is going to be inside this common folder. So we're going to create the directory common, and inside here we're going to create other folders. So I'm going to make directory common /interceptors like this, and then I'm also going to create another folder here. As you can see, the inventory interceptors folder is there, and now is filters. So make directory common filters, and the last one is going to be decorators. So I'm going to make a new folder here, common decorators. Now inside each and every one of these folders that we created, I'm going to be creating a .git keep file, because Git doesn't go on to track empty folders. So I'm just going to be creating a git keep folder here. This doesn't have any effect to our code. This is just so that Git can go on to track this. So this is the file, sorry, not folder. And I'm going to copy this file, and actually every folder we have created, I'm going to be pasting it right in here in the filters. Same for the interceptors. So you just want to go on and just keep these over here in all these folders that we have created. Same for the inventory, the notifications, the orders, the payments. I think that's pretty much it. And we're actually missing one, and that is the audit folder. So let's come into the audit folder, and let's also paste this in here. Now that we have this here, the structure is in place. We are going to wire up NestJS system itself, starting with registering the event emitter module, which is going to be at the roots of the application. I'm just running a test over here to make sure that our application can still start. And yes, our application starts. The changes we have made so far doesn't impact our code. And then we're going to, as I said, register the event emitter module at the roots of our application. Next. We are going to be setting up the event emitter module right now. This is actually a small step, but it's one that is going to turn on the entire event system for application. So over here in the application module, in the imports array, we need to bring in the event emitter module, which will come from at NestJS /-emitter. We're going to call for root. We're going to pass in some configuration here. Wildcard we're going to set to true. And then we're also going to set the delimiter to be dots like this. The delimiter dot option over here is going to let us to write event names like the order.created, and it's also going to let us to subscribe to order.events in actually one listener. We do not have only these two options here. We can also pass the maximum listeners, and we're going to give this a value of 10. And this is going to emit a warning if more than, or if we have many listeners more than this that are attached to one event. And then we're going to have the verbose memory leak to true, which is just going to also surface some warning if the event memory leakage looks a little bit abnormal. And then we're going to ignore errors, which we're going to set to false. Now, ignore errors set to false is actually important because this is actually what is going to help us to show the errors, because some event listeners can go on to swallow the errors. So we need this. Then we're going to register the configuration module. We call for roots, and we are going to say is global true, and we're also going to give it our environment file path. And the .env file path we are going to provide is going to be a path to our .env file. So let's set up this configuration. Is actually needed over here so that the Redis connection information is going to get everything that we need. Now in the main.ts file, we're going to wire up the global validation pipe. So somewhere around here, we're going to say app.use, and we're going to say use global pipes. And here we're going to pass the new validation pipe like this. And we're going to pass also some options such as whitelist to true. We're also going to set the forbid non-whitelisted, which we're going to set to true. And then we're going to set transform, and transform is also going to be equals to true. Now that we have this done over here, this is pretty much the setup. We have gone on to turn on event emitting for our application. Now that the event system is live, we are going to give it something real to emit, starting with the orders module, which we are going to be setting up next. Now let's go on to build the first real module, which is the orders module. This is going to be the entry point for everything else in this system. So I really want to make it clean before we can go on to bring in events near it. I'm going to delete the git keep, and here we are going to create the DTO folder, and let's start with the create order dto.ts file. In here, we're going to start by bringing in the different imports that we need. We're going to be importing type. Type is going to come from class transformer. We are also going to be importing is array. So all of these from class validator, is not empty, is number. We also need is positive, is string, is UUID, and also validate nested, so that we can validate nesting or nested objects here, which we'll see in a moment. And then we need to then go on to define the order item DTO. This is going to have the product ID, which is a UUID of type string. And also the quantity is going to be a number, a positive number like this. So quantity is going to be of type number. And then we're going to pretty much have the same for the unit price is number, is positive, and the unit price is of type number. With these, we can go on to export the class create order DTO. Now the create order DTO is going to take the user ID of type UUID. So this is a string, and then is array. And we want to validate nesting here because this array is going to contain objects. So we're going to say each is going to be true. And the type here is going to be the order item DTO class that we defined. We do not need this to be empty, so it's required. And the item is going to be the order item DTO list here. I'm going to get rid of a string, and then I'm just going to add exclamation mark here so that the errors can go away. Now that we have this done here, we have three pieces. The first that we have created now is the DTO. And as you can see over here, you can notice that I'm not just validating the top level items. I also have the nested order item DTO, which is making use of the validate nested and also the type, because an order without validated line items is how you're going to end up with things that you do not need in production. So you can have totals that are not adding up in production. So you want to make sure you are actually having validation on also the schema level and also the database level. You can also see the user ID and the product ID are of type UUIDs, and the quantity and the price has to be positive number. And we have also already set this up in the validation pipe. Now the second is going to be the service. So before we do that, let's create the entities actually. So we're going to have the order entity.ts file because we do not have a database or an ORM. So here we're going to import the order item DTO, which will come from the DTO folder and the create order DTO file. Let's export the type, the order status, which is going to be pending, confirmed, or failed. And we can go on to export the class of order. And this order class is going to take the ID string and also the user ID of type string, and the items is going to be the order item DTO list. The total is a number, the status is this order status we defined here, and the created that is going to be a date. Now we have the order entity, the same error. I'll just add the exclamation mark here so that TypeScript is knowing that this is going to be set from outside and not within this file. We can go on to create the order service. So let's create the file over here. We're going to be creating the order service TS file. We start by importing injectable and also logger. So whenever we create an order, we're going to log it in our application. They would all come from NestJS common. We also need to import random UUID from crypto so that we can just generate an ID. We're also going to bring in the create order DTO, which will come from the DTO folder, and in there we have the create order DTO. We also need to import the order, which will come from the entities and the order.entity. We're going to mark the class as injectable, which is the orders service. Then we can export the class order service. So this is the class definition. Let's have the logger instantiated. Read only logger is going to be equals to new logger, and we're going to pass the orders service name. Then we're going to make use of in-memory store for this tutorial. So we're going to have private read-only orders is going to be a list of orders, which is going to be an empty array getting started. Now create is going to take in the DTO of type create order DTO, and it's going to return an order. Now let's calculate the total making use of reduce function. So we say DTO.items.reduce. These are the items coming from the client. We're going to get the sum and the item. So we're going to add the quantity to the sum and multiply by the unit price. And the initial number is going to be 0. Then we can have the order, which is of type order to get TypeScript help. And the ID is going to be random ID from crypto. And we're going to get the user ID from the DTO. So the client needs to pass the user ID. The items is going to be the DTO.items. The total is going to be from total we calculate up. The status we are going to default to pending. And the created that is going to be a new date. Now we have the order. Let's push it to our in-memory order here. So this .orders.push, we're going to push this order. Then we're going to log it to the console. This .logger.log. Let's say the order with this ID is created for user with this user ID. And we want to make sure we return the order. We're going to have two methods in here. The next method is to find one. So find one is going to take the ID of the order you want to find, and it's going to return the order or undefined if it's not able to find a match. So we're going to return this .orders.find. Find method is going to take in the order, so each item in the list, and it's going to make the comparison like this. And finally, we're going to have the find all, which is going to return a list of orders, and we're just going to return these .orders over here. Now, something you can go on to see over here is that the service right now is an in-memory array, so we do not have a database yet. And that's actually intentional because I intend to keep this tutorial just to focus on the event architecture. So we're not working or focusing on persistence here. So I'm actually keeping the storage as simple as possible on purpose. As you can see, the create just goes on to calculate the total on the server side because you never want to trust what is sent by the client, and then it builds the order, it stores it, and it logs it. Let's create the orders controller. Now in the controller, we're going to be importing all of these from NestJS common. So we bring in body, we bring in controller, we bring in get, decorator, the not found exception, the param, and we're also going to bring in post from NestJS common. We're going to bring in our DTO and also our service. So the create order DTO is going to come from the DTO folder, and in there we have the create order.dto file. And we need to import our orders service, which is going to come from one level up and the orders service. Now the controller path is going to be orders. So we have the controller. So our API/orders is going to be handled by this class, the orders controller. And in the constructor, we need to instantiate the service so that we can discuss our in-memory database. So we say private read-only orders service is of type orders service. And let's have the first route handler. So it's the post decorator, and we have the create, which is the actual route handler. It takes in the body, or it gets the body, making use of the body decorator. And we can just return the service, order service.create, which then takes in the DTO. The next route handler is the find all method, which is a get endpoint. And we're just going to return this.orderService.findAll, which is going to return all the orders list. And finally, we want to check for the ID. So get find one is going to destructure the ID, making use of the param decorator. And we're going to store it in the ID variable here. And we're going to get the order by calling this.service.findOne. We pass the ID. If we are not able to find the ID or the order, not the ID, then we throw a new not found exception that the order with a specific ID is not found. And finally, we can go on to return the order if we're able to find a match. Now this is the controller, which is just a standard post orders and also get order with a specific order ID, so that we can just go on to verify that what we have created actually works. After the controller, the next thing we are going to be creating is going to be the orders module. So you know modules is used for grouping. So let's create a file over here. It's going to be the orders.module.ts file. In the modules, we are going to import module from NestJS common, the module decorator. We also need to bring in the orders controller file that we just created. So this is going to come from orders.controller, just going one level up as they are in the orders folder. And also the orders service is going to come one level up from the orders service. The class is going to be marked with the module decorator so that we can have the controller. Let's register the controller, which is the orders controller class. And also the providers is going to be the orders service. So we can register this here. And we also want to make sure we are exporting the orders service. Now, finally, we're going to have the class definition. So export class orders service. We know that having this module here is not going to be enough because we need to register this in the application module. So maybe just after the event emitter module, I'm just going to have the orders module over here. Okay, so before we just close up on this and go for the testing, remember, or I want you to notice in the orders controller, we for now do not have any event emission over here. That is actually on purpose, because over here I want you to see completely ordinary boring REST API that is first working, and the next step is for us to make it very much more interesting. Now we have the controller. Bare minimum, we are going to be testing out the controller, so the application is up and running. Then we're going to head over to the Thunderbird client, which is just a client that you can use to test your API endpoint. So it's an API client. You can use Postman, CURL, whatever you feel comfortable with. But you can install this in the extensions marketplace. But I'm going to be using Thunder client, and here we are going to test the endpoint. So the endpoint is going to be replaced with our application, and this is not /projects, this is /orders. And let's start with the post request, and over here the body, I'm just going to paste in this over here. And this is the user ID and the different items. So our validation is going to kick in here. And once you send this, you have the order created over here. Now I'm going to copy the order ID so that we can test also getting a specific order and getting all the orders. So I'm just going to copy this. And the next request here is going to be a get request. Let's just send this off like this to see that we are getting all the orders, which we are. And now let's try to go to the order ID. We'll paste in the ID and we're going to give this a send. And now we see the result over here. So far, right now, we have a real validated endpoint that goes on to create real orders. Now let's go on and define the actual event contract that we are going to be emitting, because at the moment an order is created, nothing happens. So we are going to be emitting an event once we have an order that gets created. That is what we are going to be working on next. Before I go on to emit a single event, we are going to define exactly what this event is going to look like. And I actually want to be deliberate about this because this class we're about to create is going to become a contract that every other module in this system is going to depend on. So let's close all these tabs that we do have open, and we're going to come into the orders, and here we're going to create an events folder, and then we're going to create a file, and that file is going to be the order-created.event.ts. So let's have the class definition. We are going to be exporting this class. This is the order created event class. And here in the constructor, we're going to have the public read only, the order ID. So we're going to pass the properties individually like this. Also the user ID, which is of type string. And then we're also going to have public read only items. Items is going to be of type the order item DTO array, which we are yet to import. And then public read only total, which is of type number. And then we have public read only occurred at, which is of type date. And we're going to initialize this to be equals to a new date, just like this. Let's do well to make sure we bring the order item DTO. So let's make sure that we import this. And I want you to notice the name over here. So we are making use of this name order created, not making use of a name like create order. And this actually is not a style preference. An event goes on to describe something that has already happened. And if you name it like a command, you eventually have a team member that is treating it like a command. And the team member might go on to call it directly rather than reacting to the event. And that's how tight coupling goes back to, or creeps back into an event-driven system. I also want you to take a look at the payload. We have the order ID, we have the items, the total, the timestamp, and that's it. So we are not passing the entire order entity in here. And that's actually intentional, because if inventory or payments need more details later, they can fetch it by the ID. The moment you go on and dump your entire entity shape right in here, you can't change that shape without having to break, let's say, 3 services that already depend on it. So this is how we can go on to, share or have the event definition here. Now we are going to be creating another file, and that file is going to be order event constant. So right here, we're going to create the order-event.constant.ts so that we can define the event here. I'm going to fix this typo that I have here, and I'm just going to go on to export a simple event here. So export constant order event is going to be equals to this object. So let's have the order events created, which is going to be equals to the order.created like this, and we're going to say as const. So over here, this is just a small thing that is going to save us pain. So instead of manually every time having to type order.created in, let's say, about 5 different files, and we might, go on to introduce bugs. Maybe we have a typo somewhere. We're always going to be fetching it from this file. All right, so now we have gone on to define the contract. We need to actually emit it from the orders service the moment an order gets created. Now we have a valid endpoint and we have an event contract we have created. We need to make sure that we connect both of them together. We're going to be doing this in the orders service. So let's come over to the order service. And first thing we're going to do is to have the constructor so that we can initialize the event emitter. So right here in the constructor, we'll say private read only event emitter is going to be of type event emitter over here. Now this event emitter that we have over here is the same event emitter that we set up earlier. So I'm actually referring to this event emitter over here that we did set up in the application module. Now that we have it, we need to go on and actually call the event. So we're going to call the event just after the log over here before we return. The order is actually important. I'll explain that in a moment. We are going to call this .event emitter.emit. We want to emit the event, which is the order event.created. So from the constant, you need to import it. And then we're going to, the value is going to be the new order created event class. And this is going to take in the, let's import it first. And in here, we need to pass in the order ID. So this is going to come from the order.id. The user ID, same from the order items, order.items, and also the order.total like this. Now I want you to pay attention to where we're actually calling this or emitting this event. And the reason we are doing it here just after we push, which is like writing to our database, is deliberate, because if I had emitted this event first and then the save somehow fails, every listener that is listening downstream, so the inventory, payments, notifications, they are going to be reacting to an order that doesn't actually exist. And that's what is called a phantom error, a phantom event, which is a nasty class of bug because it only shows up under failure conditions and you'll not be able to catch conditions like this, let's say during demo or during testing. And now we just have the event, and the event is actually simple. We give it the event name, and then we give it the event values. Now we are firing the event whenever we go on to save an order. Let's build the first listeners, which are actually going to go on and react to the event. Now we are going to be building independent listeners. So the inventory listener, I just want to close all these tabs that we have here, and we're also going to create the notifications listener. Let's start up with the inventory listener. So here we're going to create a new file. This is going to be in the inventory folder here, and we're going to delete this git keep that we do have here, and we're going to be creating the inventory listener here so that we can listen to the order created event, do some inventory logic, and the same for the notification. I'm going to start by bringing in the importing injectable and also logger from NestJS common. We also want to bring in the on event decorator. This on event decorator is going to help us to listen to specific events. So this is going to come in from NestJS event emitter package, and we are going to bring in the order created events, which is the order type that we're going to get from the order created event. Now this is going to come in from the orders, the events, and the order created.event file. And next we need the order events, which is going to come from the constants so that we can listen to the order events.created. I'm going to mark the class as injectable over here. So just after the imports, let's have at injectable, and we can go on to export the class, the inventory listener. Over here, we just want to also have some logs. So we're going to say private read only logger is going to be equals to a new logger, and we're going to pass in the inventory listener name. And now we're going to have the on event decorator. And what is the event name? This is the order event.created. And in here, we're going to have this handle order created handler, which is going to take in the event automatically by NestJS, which this is then going to return a promise that results void. Over here, we're just going to log to the console something that says like reserving stock for order. And we also want to have the event.order ID. Also, we might want to also list the event items length in parentheses and have the items like this. And we're going to go or loop through the different items. So we have seen this whenever we are creating an order, we pass in the items. So we loop through the event items. And now we're just going to log here. Let's go on to assume. This is actually a placeholder for a real stocking reservation call against an inventory data store that you would do in your production application. But we are keeping this simple over here by just going on to have this log that says the reserved item for this product. And we're also going to go on and log that the stock reservation complete for this specific order with the event.order ID. So now this is the inventory listener here. We have the on event decorator. These errors, I'm just going to get rid of the async here because we are not having any await, but in a real application, you're going to have async, obviously await, IO calls, database calls, stuff like that. But when this on event is going to be called automatically by NestJS for us, and you can see it's going to take in the event, which is on event type. So it's the created event. And we are going to have the event handler, which is this order or handle order created event over here. This piece of code is going to get called and is going to take inventory for your application. All right, so this is the inventory listener. Let's also set up the inventory.module.ts file so that we can group everything together. We're going to be importing module. Module is definitely coming from at nestjs/common. And then we're also going to import the inventory listener from the inventory listener file that we just created. So we're going to go one level up and bring in the import. Next, we're going to have our module decorator so that we can pass in the providers. And this is going to be the inventory listener provider. And we're then going to export the class inventory module. So this is the inventory listener and the module. We're going to wire this up in the app module later, but let's go on and work on the notifications listener. So I deleted the git keep and I'm going to create this notifications.listener.ts file, which is very much likely to what we just did on the inventory. So we are also going to import injectable and logger from NestJS common. And we are going to bring in also the on event decorator, which takes in the event as we just saw. And this will come from at nestjs/event emitter. We're also going to bring in the order created event. And the order created event is going to come in from the orders, the events, and there we have the order created.event. And let's have our class that we're going to mark as an injectable. Actually, we need to bring in the order events. Yes, this will come in from our constants. So after this, we can finally go on to mark the class as injectable. So I'm going to come here, have the injectable, and export the class, the notifications listener. So in this class, we are also going to do some logs. So private read only logger is equals to a new logger, and we're going to pass the notifications listener name here. And on event decorator, so on event, the order event.created, we are going to have the async handle order created, which takes in the event of type the order created event, and it's going to have a promise or return a promise that resolves to void. We are still going to log over here the sending confirmation email. So we are faking that we are sending a notification in our application with the event or order ID to a specific user. And here we're going to also have the log. So this log we are going to be listing over here is just a placeholder for a real email provider call. So SES, resend, postmark, whatever you're using. And this listener here doesn't know anything about inventory or payment. It just goes on to react to the event that it cares about. And here we are just placing this log over here, faking that we are sending a real email to the user, a confirmation email to the user like this. Now that we have this, what is going to happen? I'm going to fix all these linting errors that we have here by removing the async and by also removing the promise, because we do not have any asynchronous call over here. And we are going to go on to do the next thing, which is create the notifications.module.ts file. And this is also going to be so simple and straightforward because we just need to mark this as the provider, that is the notifications listener. So we're going to be importing module from NestJS common. We're also going to bring in the notifications listener, which is going to be coming from one level up, and we have the notifications.listener. And we are going to have the at module decorator, so we can mark the provider here, the notifications listener. And we can go on to export the class notifications module. Now we have two listeners. We have the notifications listener and also the inventory listener. We are going to be registering both in the application module. So right here in the application module layer, just after orders, let's have the inventory module and let's also have the notifications module listed over here. Now we have two listeners. These listeners are reacting independently. Now we are going to add a third one that doesn't care about the business logic at all. You're just going to go on and do cross-cutting auditing. We are going to be creating the audit listener next. We are going to break our application soon, but we need one more listener. We currently have the inventory and the notifications listener that are both subscribed to one event, which is the order created event. Now, audit is going to subscribe to the order wildcard event, the entire namespace. And this is exactly why we turned on wildcard true and also this dot delimiter in previous step. Without this exact configuration, this decorator, so the decorator we are going to make use of is going to fail and it's not going to match anything. Okay, so this really matters because audit logging is actually a cross-cutting concern. It doesn't actually care about the specific business meaning of, let's say, a specific event. So it just wants to go on and have a record that something happened to an order. And right now, we only have one event, which is the order created event. But the moment our system grows, the moment your system grows, you have something like the order canceled, the order refunded, things like that. The same listener that we are going to be creating is going to work without having any code change. All right, so we are going to be working on this audit here, on this audit log. And we're going to start by creating the audit log entry file. This is the file we are going to be creating now. So I'm going to close all these tabs that we do have open. And in the source, we have the audit. And right here in audit, I'm going to delete the git keep that we set up initially. And here I'm going to create the audit-log.entry.ts file, which is going to be an interface. So the shape of a single audit record. Okay, so we're going to export the interface, the audit log entry, which is going to take in the order ID of type string. We are also going to have the event namespace of type string. We are also going to have the capture that of type date, and the summary is going to be of type string. This is the shape of the single audit record. And as you can see here, it's actually kept independent of any specific domain event class. So the audit only needs to know that something happened to a specific order at a specific time, which is not going to need a full internal payload shape over here of every event that it might go on to receive. Let's go and create the audit listener file. So we're going to create this audit.listener.ts file over here. And here we're going to import injectable. And we're also going to import logger from NestJS/common. And we're going to also import the on event. This on event is going to come in from at NestJS/event emitter. And we're also going to bring in the order created event. The order created event is going to come in from the orders and the event, the order created.event file. We are also going to be importing the audit log entry that we just created. So the shape, the interface, which is going to come in from the audit log entry file. Now let's have the class, but first, as always, we'll mark it as injectable. We can then go on to export the class, the audit listener. And here we want to inject the logger or create the logger instance. So private read-only logger is a new instance of the logger class, which takes in the audit listener name. And then we're going to have the private read-only entries, which is going to be of type the audit log entry. So this is just an in-memory audit trail for this tutorial. A real system is going to, go on and persist this to a dedicated audit table. So here we have the on event order here. Then we're going to have the order handler, which takes in the payload of the order created event, and it's going to be returning void. We're going to say const entry of type the audit log entry is equals to this shape. So we have the order, which is the payload.order ID. We also have the event namespace, which is this white cat that we have over here. So this is the audit log entry type. The capture that is going to be a new date, and the summary is going to be the order with the payload.order ID, and we're going to have the total with the payload.total, and we're going to call to fix2, and we also want to have the payload items length and the items noise. I'm going to collapse this shortly, and we can close this up here. Now we're going to push the entries into the array. So we say this.entries.push this entry, and we're going to go and log that the audit has been entry has been recorded, and we're going to put the entry.summary over here, just like this. We are logging this to the console. We're also going to have a find all so that we can get all the audit log entry lists, and this is going to just go and return this.entries over here. So I'm going to close this up and fix the linting errors that we have. So fix this, and I'm going to remove the async, and I'm also going to remove the promise that resolves to void that we have over here. We have this wildcard subscription which matches every event in the order. So this order.star over here. So if it's an order created, everything is going to go on and match this. Now let's create the audit module.ts file so that we can register this here. And we're going to be importing module from NestJS common. We're also going to bring in the audit listener, which is going to come from one level up the listener file that we just created like this. And we are going to have the module decorator. So I'm going to have the @module decorator. The providers is going to be the audit listener, and the exports is also going to be the audit listener, and the class is going to be the audit module class that we export. And now we need to register this new class in the application module. So let's come over to the application module, and here we are going to register this new class over here, just like this. Now we have successfully created the audit module. This audit module is actually helpful. Let's go on and test things. So I'm going to say npm run start dev so that we can go on to test everything that we have worked on before we go on to break it and fix it. And yes, so our application is currently up and running. Let's go on to test everything out. So you want to come over to your Thunder client over here. And here in Thunder client, I'm going to click on this get orders here. And in here, we are going to try to create a new order. So what's going to happen, I'm going to keep this body shape over here because we are just doing all of these in memory. We are not writing to database. But this is going to be a post request, and I'm going to remove all of these. So we just have the orders path. And now if you go on and send this, we actually create an order. But let's take a look at the logs over here. So I'm going to open up the terminal here. And here, let's see what gets printed. So you can see over here in the terminal, we are seeing the order service is logging that the order was created for this user with this ID. We also see over here the inventory listener is reserving stock for this order here with one item. So we see the log here. We also see the log from the inventory that we reserved 2 products here for this ID. So product here, we see the inventory, and we also see the notifications listener. And you can see down here, we also have the audit listener here. So all of these are coming from the different listeners that we did set up. So if you check the inventory and the notifications listener, you can see here we are logging this when the order gets created. Here we are sending notification email to the user, and we are also having some logs, which we see printed over here. That's actually the same idea. That's the same thing that happens for the inventory listener. If we come over to the inventory listener.ts file here, we can see we are also reserving stock for this order, and we are also logging the quantity here, which are the logs that we see over here as well. And if we also double check the audit listener here, you can see in the audit listener further down here, we are logging that an audit entry has been recorded, which we also see that gets printed here. So we have 3 listeners that are now reacting cleanly to one specific event. Next, we are going to break one of them, and we're going to see how the failure or how our application reacts when one of our listeners gets broken. Now I'm going to be breaking our application on purpose, and I want you to actually see what's going to happen. So let's break the inventory listener. I'm going to come over to the inventory listener here, and I'm going to throw a new error over here. So somewhere around here, I'm going to be throwing this new error here that's going to say inventory service unreachable, and I'm also going to say connection refused, like this. Now let's see what happens whenever one of our listeners gets broken. Let's see how our application reacts to this. We wait for application to build, and currently it's built, as we can see, and we're going to be I'm going to have this at temporary here because this is just temporary check that we have here. And let's go on and test this out. So what's going to happen, I'm going to come back to Thunder Client, and over here in Thunder Client, we're going to try to create an order so that we can see what happens. So now we try to create an order. You can see that the order actually gets created. So our API is returning 201. Everything is fine. Now we see this NestJS error over here. NestJS actually goes on to log this error that we see over here. So we see it here in the terminal. It has this square brackets NestJS here, which says the inventory service unreachable, connection refused. So we see the full stack trace and everything. So this is NestJS event emitter that goes on to catch the error internally so that it doesn't go on to crash the NestJS process. So I really want to be precise about this because this actually is an error that we are seeing over here. But take a look at this log. It doesn't give you much information. It's tagged events, generic framework level error that you're going to see over here. No idea which order this was actually. So you no longer have this correlation to the request that triggered this specific error that you have over here. So you do not have any hook monitoring tool that you can actually use. And most importantly, take a look at the response that the client gets on to get. The client is getting a 201 success over here. Now, as far as anyone is concerned, calling this API, this order is fully processed and the stock was never reserved. Now we are going to be fixing this. We are going to be building an error handling that is actually structured, gives more context, and is connected to something that can actually go on and act on this. Let's go on and create a much more robust error handling logic. We have seen that NestJS event emitter already logs uncaught listener errors internally, which we see over here. This is useful because the application never goes on to crash, but what it doesn't give us is control. We do not have any correlation ID. We do not have any business context, and business context, I mean which order or which listener this error is coming from. We do not have any hook into our own monitoring stack, and there is no way to distinguish a real problem from the framework noise that we have in the logs. This step, we are going to replace this generic uncustomizable log line with our own structured actionable handling, which is going to add a process level safety net for anything that isn't wrapped up this way. I'm going to close this, and I'm still going to leave this over here, and here we're going to be creating a new file, and this is going to be right inside the common folder. Here in the common folder, we are going to be creating a new folder for utilities. So this is going to be called utils, and here we're going to be creating a new file, which is the safe listener utils.ts file. Inside this file, we're going to be importing logger. Logger is going to come from NestJS common. And here we're going to say const logger is going to be equals to the new instance of the logger class. And the name here is going to be the event listener error name. We're going to export this async function, which is the safe listener. We need the listener name as well as the event name. They are both of type strings. We also need a function. This function is going to return a promise that resolves to void. And this safety listener function is also going to resolve to void. In the try block, we're going to await the function, but in the catch block, we just get the error. And we're going to say error is going to be equals to error as error. What we're going to do, we're going to go on and log the error. So we say logger.error, and we pass the listener as well as the listener name and said this field while handling this specific event. And we also want to have the error message. And then we're also going to attach the error stack to the logs. Now in a real application, you might have something like Sentry, which you can call to go on and capture the exception, where you can forward the error and have different tags just like this. And that's why I'm leaving this comment over here. What we have over here is a save listener, which is a small utility that takes the listener's name. It also takes the event name and the actual work as a function. Then it goes on to run that function that we take in here in the try catch block. And if anything throws, it goes on to log a clear structured message with a real context. So things like which listener, which event, the actual error. And as I left this comment here in a production system, this is exactly where you would actually go on to call Sentry or something like a Datadog. So one place, one convention, and every listener is going to be reporting following the same way over here. Now I'm going to be wrapping all three listeners with this. So the inventory, the notifications, and also the audit, not just the one that is currently broken, because over here, consistency really matters. If one listeners go through structured handling, then you've got different debugging experiences, and depending on the one that fails, it can get a little bit confusing on how you can go on to handle that specific error. Let's go on and fix this and wrap all three listeners with this safe listener that we have over here. Let's start up with the main.ts. The main.ts is what I would like to call a last resort safety net here, because every listener in the code base should go on to be wrapped with this save listener function that we have. But if for some reason the error sneaks out, or maybe it's not wrapped with this safe listener, this main.ts, as I said, is going to be like a last resort safety net for our application. So what is going to happen is just after here, we have the application, or maybe before we even have the application, we are going to create the logger. So I'm going to do that right in here. Over here, I'm going to say const logger is equals to new logger, and we're going to pass in the name of bootstrap like this. And on process.on, we are going to have the unhandled rejection, which is going to have this callback function that takes in the reason automatically. Then we can make use of the logger.error to log the error over here, unhandled promise rejection, and we're going to pass the reason. We're also going to have another promise.on over here, and this is for uncaught exception. So the first one is for unhandled rejection. And here we're going to get the error, and we're going to also make use of our logger just so that we can log it to the console, the uncaught exception with the error.message, and we also want to have the error stack over here. Definitely we have the error because logger needs to come in from NestJS common. So here, let's make sure we bring in logger from NestJS common like this, and we can fix this linting that we have over here, just like this. If you have this error over here due to linting, we can just go on and cast this to be of any type, just like this. And once you do that, you can see now the error is gone, and you can go on to save this file. Now let's go over to where we currently have the error, because if you open up your terminal, you can see this is coming from the inventory service over here. So I'm going to come over to inventory, and over here in the inventory listener, this is where we are currently throwing the error. And how can we go on to make use of this our save listener? I'm going to cut all the code that we have over here. So you want to make sure you cut this, Control X or Command X. And over here, we are going to await, and we're going to be awaiting our save listener, which needs to be imported. And this is going to come from our utils file. And here we are going to wrap this. You can see this takes in the listener name. Now the listener name we are going to be passing over here is going to be the listener name of the inventory listener.name. So here we're going to have the inventory listener.name like this. And the next thing it needs is the event name. The event name is going to be the order events, and here we're going to pass the created as the name. And you can see the next thing it needs is the actual function. So I'm going to come over here, and I'll just mark this function as async, just like this, because the third argument it needs is a function. And then inside this function, we can then paste in the code that we had previously. Now, if you have linting errors, you can just fix the linting errors you have just like this, and the application should be good to go. So the reason why we have this error over here is because we do not have any await expression. So we can also get rid of this error by coming here to mark async. Now we know then the error is going to continue because this entire function is not returning anything. I'm just going to come here, and here I'm going to say this is going to return a promise, and this promise is going to be resolving to void like this. And now this fixes the error that we have over here, but we still have this error here as we do not also have the await expression here. So we can remove the async that we have here, and then we can fix the linting errors that we do have, and our application is fine. So all you need to do is to remove the async that you have over here, and this is good to go. I'm going to give this a save, and then I'm going to open up the terminal window, and I'm going to give this another trial. So let me clear the window from what we had previously, and then I'm going to run npm run start dev command. So while the application boots up, this time around, let's come over to the Thunder client. And over here in Thunder client, if we come over to /orders, and let's send this request again. So I'm going to send this post request, and let's take a look at the terminal this time around. We see that we still get the status of 201 and the order gets created. Now we can see that this actually works. It might look similar to what we had previously, but if you take a closer look here, you can see now we have the listener and we have the inventory listener. This is not what we had previously. And we see that this failed while going on to handle the order.created. So it lists the event, and we see the inventory service unreachable. And now we see the actual error over here. And this is what we wanted to achieve so that we can have good error handling across our different listeners. I'm going to collapse this, and I'm also going to, then at this point, I'm going to remove this temporary code that we have over here, because now we have proof that everything works. But let's give this a save. Now to fix this error that we have over here, let's come back to the save listener. Let's see if there's something we can do. Now this function needs to be returning a promise that resolves to void. So what if we try and say this should return void in itself? Now this goes on to fix the challenge that we had over here in the inventory listener. We are going to be doing the same thing, but this time around is going to be for the notifications listener. So let's come over here and let's look for the notifications. So outside common, you want to be in notifications, and here in the notifications listener, I'm going to cut all of these that we have over here. So these two. So let's cut these. Now we're going to await our save listener. So let's bring in the save listener, which is going to come from our utils. We know that this needs the listener name, and the listener here is the notifications listener. So this is the class, and now we have the name property, and it also needs the event name. We're going to call the order event.created. And finally, we are going to have the function. So I'm going to also mark this as an async function like this. And in here, this is where we have the actual work to be done. And then I'm going to paste this in here like this. And let's start by fixing any linting errors that we might have just here. Definitely, we still have the async and await errors that we have here. So in order for us to fix this, let's see how we did fix it in the inventory listener. So we marked the promise as, or the function as a promise that returns void. So I'm going to do the same here. I'm also going to have promise and say this is going to be returning void like this. So that means we can come here first, and let's also mark this as async. So marking this as async fixed the error that we have over here, but we still have this error over here because we do not have any await expression. So that means we can also get rid of the async that we have over here. And then we can go on to fix the linting errors, and our application should be fine. I'm going to give this a save, and we're going to do the same thing for the other listener that we have, which is the audit listener. Let's come over to the audit listener, and here I'm going to click into here, and I'm just going to, as always, cut all the logic that we have in here. So I'm going to cut all of these, And then I'm also going to await our save listener, which needs to be imported from the common folder. And here the listener name again is going to be the audit listener.name. It's also going to take in the next argument, which is the event name. And the event name we are going to pass over here is this wildcat. So this is a wildcat. So what we can say here is order dot and star like this. Now the next thing it needs is the function. So over here, I'm going to have the async function here like this. And in here, I'm going to paste the previous code that we had. Definitely, we start having the errors that we have, both from lengthening and also the async errors. So I'm going to come here and mark this function as async. And here I'm going to say this is going to resolve to a promise like this. And the promise is going to return void over here. Now the last thing to do is for us to get rid of the async that we have over here, as we do not have any await, and this has been fixed and our application is fine, and I'm going to give this file a save. So there is it. We have the same underlining error, but now it is our own error, our own listener name with our own event name and our message, and actually in a very good format that we can go on to control. And we can also go on to route it to anywhere that we want. Currently, failures are now visible, but the event emitter 2 is still memory only. So next, we're going to bring in Redis and also BullMQ so that we can make events go on to survive a crash. That is what we are going to be working on next. Everything up to this point has lived entirely inside our NestJS process. That's actually about to change because durable events need somewhere durable to live, and that is Redis. I'm not going to be installing Redis on my machine directly. I'm going to be making use of Docker Compose because that's how you would actually run this in a real team. Anyone who goes on to close this repository is going to run one command and have the same identical Redis instance without going on to do any manual installation. So this is going to go and work everywhere. Now, for you to make use of Docker Compose and run this also on your machine, you need to have Docker installed on your machine. You need to come over to docker.com if you do not have Docker installed on your machine. And if you come over to products, you see over here, we have the application development section. You want to come over to Docker desktop here. As you can see, containerize your applications. And this is going to take us to the product section where we can download Docker for your local machine. Now you see here, download Docker desktop, and here you have different presets based on your operating system. So on Mac, Apple Silicon, Intel chip, Windows AMD or ARM, or also for Linux, you can go on and download Docker on your machine. Once you have Docker installed, you want to make sure that Docker is running. So you want to see this whale icon here. This whale icon that goes on to say Docker desktop is running. Once you confirm you have Docker installed, let's go back to the code base and create a Docker Compose YAML file. Over here in the project, I'm going to close the previous work we have done, and then I'm going to open up the Explorer section, and I will just collapse all of these. Now, where do we create the Docker Compose YAML file? It has to be over here in the root of your application. So here we're going to be creating a new file, and this new file we're going to create is the docker-compose, just like this, .yaml file. So in here we are going to have a service for Redis. Let's do that. So here we're going to have the services, and then we're going to have the Redis. The image for Redis is going to be the Redis image with the 7 Alpine package. And the container name is going to be the NestJS event-driven orders Redis. This name is for us so that we can go on to manage the container. And the restart command or option is going to be on let's stop. Now the ports on our machine 6379 is going to map to the Redis 6379 container port. The volume is Redis data /data like this, and the command is Redis server append only yes. So -- append only yes. And we are also going to have health check. So for test, the command here is going to be the Redis CLI ping command. The interval is going to be 5 seconds. We're also going to have a timeout of 3 seconds and a maximum retries of 5. And for volumes, we are going to have Redis data. Now that you have this, the env file already exists. So here you just want to make sure that you have everything like this in your env file. You want to make sure that this Redis port over here and the host points to localhost like this. So you just want to go on and double check you have this like this here. Now you also want to make sure that in your git ignore that you also have Docker related ignores. We already have the .env, which we have confirmed. We already should have the node modules somewhere here, which we do. And we also have the distribution folder over here. So now let's go on and make sure that everything is up and running. I'm going to open up the terminal and I'm just going to quit the terminal for now temporarily like this. And here you want to run the command docker compose up -d. So -d is in detached mode, and you can see over here we have all of this up and running. Now, how can we go on to test that the container is actually up and running? So let's check the container status. The command is docker ps or docker compose ps like this. Let's go on and send this, and you can see over here we have the NestJS event driven orders Redis. With this image, we have the command. We can see that this was created 17 or 18 seconds ago, and the status is up and running and it is healthy. Now that we have this, I'm going to execute a command just to ping the Redis CLI to see if we get back a pong response. So here I'm going to say docker execute like this, exec it --it, and here we're going to have the NestJS -event -driven -orders -redis, and then we're going to set the Redis CLI Redis -CLI, and we're going to send this ping over here. And now we should get back the pong response like this. Hello everyone, so we have verified that Redis is running, and it is actually verified, and we have our NestJS application connected to it. I want to be precise about what this step we are about to perform, what it is and what it isn't. We are not going to be creating a queue yet. We are only going to establish the connection. BullMQ is going to use once queues goes on to exist in the next step after this step we are about to create. Now, the reason we can go on to split this apart, and the reason why this matters, is because if something breaks, you're going to be able to know immediately whether it's a connection problem or whether it's a queue configuration problem. So in the application module, I'm going to be registering the BullMQ module for root async. So let's come over here and come into the application module, and I'm just going to collapse this for now. I'm going to be doing this just after the event emitter module, so just here. And over here, I'm going to call BullMQ, which we haven't imported. So the bull module for root async, and the import over here is going to be the configuration module. And we are going to be injecting the config service. Now we can also go on to make use of the factory, where we are going to get the config service here. And we get this here because we are injecting the config service, and in here we're going to return this object where we have the connection. So the host is going to come from the environment variable. So here we get the Redis host and the local host like this, and the port over here we are also going to get the port which is of type number. So this is the Redis port 6379 like this. Let's make sure we bring in whatever is required. So we need to bring in the bull module. So I'm going to bring this in from NestJS BullMQ like this. We also need to bring in the config service, which is going to come from our NestJS /config. And then we can go on to give this file a save. This is the only setup we need to do over here. And now we can go on to test this up. So I'm going to open up the terminal. Let's just double check that our NestJS application is still up and running. So I'm going to say npm run start -dev like this, and I'm going to send this to know that, hey, connecting BullMQ or registering the bull module actually works as expected. And after this, we can then go on to create the queues. So we can see now connection works. Now let's focus on creating the queues. So previously we have our Redis connection, and currently the Redis connection isn't doing anything. So we're going to be giving it a first real queue, and I'm going to be installing some packages for this. So remember in the beginning I tried to install some packages, but now we need to install more packages. We are going to be installing the following. So I'm going to say npm install at bool-board, just like this. And this is going to be /API. We're also going to install at bool-board/express, like this. And I'm going to collapse this. The next one is going to be at bool-board and then /NestJS. This isn't strictly required to make use of BullMQ, but I want a visual dashboard for the rest of this tutorial, because trust me, you don't want to say like the job is in the queue. That's a really bad way for you to go and reach this. You want to go and see every job that we create for the rest of this video in real time, and you want to see this also in the browser tab. So we're going to be creating the queue over here, and let's start with the queue name. Now in here, I'm going to close this. We are going to create a new folder for queues. As you can see, we do not have any queue over here. So in the source folder, let's create a queues folder like this. And in here, we are going to create the first file. This file is going to be the queue constants.ts file, like this. Now in here, we're going to just export this constant, which is the queue names. And here we're going to have the other events, which is going to be the other events here, and this is going to be registered as constant. Now, after having or creating the queue constants, the next thing we're going to be creating is actually going to be a queue module. So I'm going to fix the error that we have over here, and let's come here and create a new file. This new file is going to be the queues.module.ts file, just like this. And before we actually continue, I just noticed a little typo here. This should be queues, like this, and I'm going to save this. So let's come back to the queues module, and we are going to start by bringing in the module decorator, which will come from NestJS common. And after this, we are also going to be importing the next package, which is the bool module. The bool module is going to come from at nestjs/boolmq. Then we're going to bring in the bool-board module, and the bool-board module is going to be brought in from at bool-board/nestjs. Let's also bring the BullMQ adapter. The BullMQ adapter is going to be imported from at bool-board/API/boolMQ adapter. And we also need to bring in the queue names, and the queue names is going to come from one level up to the constant. Now, this is going to be very short and straightforward. We're going to have the module decorator, and the imports, we are going to have the bool module, and we're going to call .registerQ. This is going to need the name, and the name is going to be the queue names.other events, just like this. And after this, we are going to also have the bool module for feature, and we're going to give this feature name here for the queue names.other events. And then it's going to take in the adapter, which is the BullMQ adapter. Now we're also going to export the bool module over here, which I'm going to explain here in a moment why we are exporting this. But now we're going to export the class, the queues module. Now this is the queues module class, and the reason why we go on to export the bool module over here, so any module that imports the queues module can go on to do something like at inject queue and pass in the queue names.other events without having to register it again. Now that we have this, we are going to mount this in our application module. So come over to the app module, and just after the bool module over here, we are going to call the bool-board module. So the bool-board module, which is going to come from at bool-board/nestjs. So you want to make sure you import that. And here we're going to call for root. And here we're going to pass in some configurations. The configuration we're going to pass here is the route, and the route is going to be /queues, like this. And we're also going to pass in the adapter. The adapter here is then going to be the express adapter, which also needs to be imported from at boolmq /express like this. And I'm going to just quickly fix this linting error that I have over here and give this file a save. Now, the reason why we are doing this over here is because this goes on to mount the actual dashboard UI and the /qs path that we are going to be able to view. And here we are also making use of the Express adapter. Since this is actually a standard NestJS Express application, this only goes on to need this, or this only needs to happen once at the root level of the application. But over here in the queues module, we registered this for feature over here. It goes on to add our own specific queue to what we have over here in the queues over here like this. So that's how NestJS goes on to do some what feels like magic under the hood. But this is how everything is connected. Now let's open up our terminal window. And here I'm just going to make sure that our NestJS application is still up and running so that we can go over to /queues in the browser and so that we can see the board UI that goes on to render with the other events that is going to be listed as a queue, which for now is going to contain 0 jobs. So I'm going to come over to the browser and you want to go over to localhost 3000. This is the hello world that we saw earlier, but now we want to go over to /queues path. Now over here, you can see we have the bull dashboard, and here we should also go on to see that we should have our other events queue somewhere here. So let's click on active. For now, we see no queues to display, and let's see if we can maybe see for now. We do not have any active. So because we do not have any active, I presume that is why we do not see that we have already registered the other event queues over here. But when we go on to have active jobs, I expect to see the active jobs over here. All right, so we have our queue, which is live. Now we're going to replace the orders service where we have the in process emit with actually a real durable job that is going to be added to this exact queue. All right, so we have same event. We also have same data, but now we're going to make use of completely different transport, which is going to help us to make it durable. Okay. So now what we're going to do, we're going to make a little change in the orders module. So I'm going to remember what we did over here. So remember in the queues module, remember these exports that we have over here, the BullMQ module we're exporting here. This is what is going to allow us to come over to the orders module. So here where we have the orders module, not the controller. So here where we have the module, we can go on and have the imports. And in the imports, we are going to be importing the queues module. So the queues module like this. So here, as I said earlier, this export that we have over here is allowing us to come here and have this imports over here. So I'm going to go on and give this a save. Now in the orders service, so let's come over to the orders service. I'm just going to collapse the Explorer. If we come over here, so just after here, we are going to have the constructor. And the constructor, we are going to be replacing this event emitter that we have over here. So we're going to be getting rid of this just like this. I'm just going to comment this out temporarily. And over here, we are going to be replacing this with the BullMQ here. So what we're going to do, I'm going to also have the constructor. And here I'm going to have the inject queue. And here I'm going to have the queue names.order events like this. And then we're going to have the private read-only order events queue, which is going to be of type queue. Now let's make sure we bring in the respective imports that we need. We need to make sure we are bringing in inject queue, which is going to come from NestJS BullMQ. So we need to get rid of event emitter 2. We no longer need it here. We also need to bring in queue name from the constants. And we also need to bring in queue. Now queue is going to come from BullMQ. And now I'm just going to fix this formatting error that we have over here. Now we still have an error here and we're going to be fixing this. Now we were previously creating an event or emitting events. Now we're going to be adding the events to the queue rather than go on to just emit events. So what I'm going to do here, I'm just going to comment this out like this. And over here, I'm going to replace this with the order events queue. So remember over here, we said this order events queue. So we're going to call it and we're going to add to the queue. Let's do that next. So here we're going to go on and have await, and we're going to await this order events queue. we're going to add the order event.created, and this is going to be, for the value, is going to be the new order created event, which takes in the order ID, also the order user ID, the order.items, and the order total. We can go on to also pass some configuration, just like the attempts 3, which means this is going to just have a maximum retries of 3 times if it fails. Also for the backup, we're going to have this type of exponential, and the delay is 2000, just so that we do not go on and hammer the queue. We are just going to wait, and the next is going to wait longer than the previous. And here we're going to remove uncomplete 100 like this, and we're going to remove unfailed to be false. This is the configuration that we are going to pass in here like this. And this is actually everything that we need just to complete this. Now we have this await error that we have over here, and that's because we do not have this to be marked as async. So I'm going to mark this as async now. And now we no longer have any error here, but we do have an error here where we return. So this is returning a promise now, because now this is async. So what I'm going to do, I'm going to cut this and say this is going to return a promise that resolves into an order like this, and then I'm going to give this file a save. Now there's something I want to say immediately, because you see the order service over here. Previously we were emitting this, and then we had listeners. We had the audit listener, the inventory listener, the notifications listener, and you might be wondering what then happens to our listener. Now they all still gonna exist, but now they are currently subscribed to the order created event, which at this point is not emitting. So it's not going to be able to, or they are not going to be receiving anything anymore, because we just replaced it with this code over here. So right now, if I go on to create an order, those 3 listeners are actually going to go completely quiet. And that's actually expected, and that's what we are going to be working on in the next step. Okay, so let's go on and test this. We are adding an event to the queue. Let's test it and be sure that it works. I'm going to come back here to my Thunderbird client, or to the Thunder client, and I'm going to click on this so that we can go on to create an order. So let's open up the terminal here before we go on to try this, and I'm going to send this order we have been testing with. Okay, so now watch what happens. So let's give this a send. Now we see that this gets created. We get the order service. Yes, we still see this in the order service, because if you come over to the order service, we have this over here. So order created for user, which is this. So order with the order ID was created for the user. But now we can see that the listeners are quiet. We do not see any log over here, because we just commented out the line of code that was emitting to those listeners. But now let's also double check our application. Let's come over to the browser. Over here in the browser, let's just give this a refresh so that we can see that we have an event in the queue. And currently you can see we have this waiting over here, and in this waiting section we have one job. Let's click into this here. As you can see, we have the data over here with the items, which matches what we have, or what we sent over here as data. Now you can see that this has been added to the queue, which is this new class over here, and we have this configuration just like this, and that's why we see this in the queue. Now we have the data, and these are the logs that we can go on to monitor this. Our event is now durable, but nothing is consuming the event anymore. Now let's go on and migrate those 3 listeners that we had previously into the real BullMQ processor so that they can start reacting again. Let's go on. Let's migrate our listeners to the BullMQ processors, because currently, if we see here, I'm just going to collapse this. I did shut down my Docker. Maybe that's why I have these logs over here, but everything is good. Everything should be fine. So I'm going to close all these tabs that we do have open. And here you see that we have the inventory, the notifications, the listeners are currently listening to this event created, which was being triggered over here in the orders service. So over here, previously we were emitting this event, but now we no longer emit the event. We add this over in the BullMQ queue over here. Now let's go on and migrate the notifications. I'm still going to leave this file over here for reference, but now I'm going to be creating a new file, which is going to be the inventory processor and also the notification processor. So let's start up with the inventory processor. So here we're going to create a new file. And this new file is the inventory.processor.ts file. So I'm going to collapse this. We're going to make use of processor and worker host that's going to be coming in from BullMQ. So let's bring in the respective imports. Processor and worker host is going to come from BullMQ. And once we have this, we also need to import the logger. So let's import the logger from NestJS common. We are also going to be importing the job. The job is going to come from BullMQ. And then we need the order created event. Let's import the order created event, which is going to come from the orders folder and then the event, the order created event file. We need two more imports, the order event. The order event is going to come in from our constant. So remember the order event created. This is going to be coming from the constant. And we also have the queue names, which is going to come in from the queue constants. Now we have the respective imports that we need. We are going to mark this class as a processor, which I'll explain soon. So here we're going to have the processor, and here we're going to give this a queuenames.order event. And here we're going to export the class the inventory processor, which extends the local or the worker host. And in this class, we're going to have our logger, which is going to be equals to new logger, where we pass the inventory processor name. And because we're extending worker host, we need to have this async process method. This is going to take in the job. So this is of type job, the order created event, which is also going to have void and string like this, which I'll also explain in a moment. And this is going to return void. Now let's check if the job name is equals to order events created. We're just going to go on and return. Sorry if it is not equals to, because for now we just have the order events not created. Now the event is going to come from the data, so the job.data. I want to have a log here. So we're going to call the logger.log, where we're going to say what we did previously, like reserving stock for order for this specific order ID, and also the event items length, and we have the items, and we also want to have the attempt here. So the attempt is going to be the attempt made plus 1 like this, just like this. So if it's the first attempt, stops like that. Now we're going to still map through the or loop through the items, just as we are doing in the listener. And for each item here, we're just going to go on and log that the item quantity and also the item.product ID, just like this. And after this, we are then going to close this up by also having the last log, which is like confirming that everything has worked. So here we're going to log the stock reservations complete for this specific order, which we're going to get from the event.order ID. All right, so this over here, you might also notice we are missing something. Let's take a look. I'm going to close this here, and I'm going to get rid of the async as we do not have any await operation here. And I'm just going to say this is returning void like this and get rid of this here. Now let's give this file a save. Why do we have an error here? Because void is not assignable to type promise. So we see over here, if you hover on this job, you see this job is going to take in the data type, which will pass in the order created event, also the return type, which we are returning void, and also the name type, which is string like this. Now the error we have here is because the inventory process is not assignable to worker host. It needs to be an async. So what we can do, because we are returning void and you can see it's not assignable to type promise any, I'm just going to mark this back as an async function. And we do not have any asynchronous function here. So what I'm going to do is here, rather than say void, I'm going to return this to tell TypeScript, hey, we are returning a promise that resolves the void, which now leaves the error here because we do not have any async or any await. So over here, I'm just going to fake await promise.resolve, just like this, just so that we can have an await. And I'm just going to have null over here. All right, so let's give this a save. This is just, it doesn't have any implication of our code. We just have this promise that resolves to null, and we do not have anything, just so that we satisfy the fact that this has to be async. But let it not distract us. I was actually going to tell us over here in the notifications listener. Remember what happens to our save listener, because we do not use the save listener here. Now, the reason why we do not have this here, or why we do not catch errors here, is because BullMQ is going to treat any thrown error as though it's a job failure, okay? And that job failure is what is going to power the retry and backup that we configured earlier. Okay, so we are going to have a dead letter handling, which is coming in an upcoming video. But in this case, going on to swallow errors in the processor is going to silently disable the durability that this whole migration exists to provide, okay? So that's why we did not go on to handle errors over here. Now let's also go on to edit the inventory module.ts file that we have here. And now we're not going to have the listener over here anymore. We're going to be replacing this with the inventory processor here, like this. Now I'm just leaving this over here so that it can be useful, the listener. So when you come back or when you're watching this, you can see how this also works, or how it worked previously. Now we're going to do the same for the notifications. So I'm going to close all that we have here, and let's come into notifications, and I'm going to create a new file. This new file here is going to be the notifications processor, notifications.processor.ts file. And I'm going to collapse this. Let's start by bringing in the processor and also worker host, which is going to come from NestJS BullMQ. And after this, we are going to be importing logger. Logger is going to be coming in from nestjs/common, just like this. And then we also need to import job. So we're going to import job, and job is coming from BullMQ. And after this, we need to bring in the order created event, which is going to come in from the orders folder and the events folder. And there we have the order created.event file. So we also need the order events, which is going to come in from the constants. So let's make sure we are importing those here as well. And after this, the last is going to be the queue names. So we are also going to be importing the queue names, which is going to come in from the queue constants. So this is going to be pretty much straightforward. And here we're going to have the @processor, just as we had for the previous one. And this is going to be queuenames.orderEvent. And we are going to be exporting the class the notifications processor, which is going to be extending worker host. We are going to have the read-only logger. So private read-only logger is going to be equals to new logger. And we're going to pass the notifications processor.name. We are also going to have the async process. This process is going to take in the job, which is of type job, and it's a generic type where we can pass in the order created event, void, and string like this. So the event name, the return type, and this is returning promise that resolves to void. Now we want to make sure we are not handling events where the name is not created or the event that are not created. So we're just going to go on and return. And here we're going to have the event, which we're going to retrieve from the job.data. Then we're just going to do, very simple and straightforward. This is where you would actually send your notification, but now we're just going to fake as though we are sending notification to the user. So we're just going to leave this log over here that sending confirmation email for this order to this specific user, and we also want to have the attempt here. Now the next thing we are also going to go on and log is that this here has been queued for the order with this specific order ID, and also we're going to have the total, which is like the amount. Okay, so this is just what we were doing previously in the notification listener, okay? But now we are working with the notification processor. Okay, so now that we have all of these here, I'm going to just go on and close this and just fix the same error as we had previously. So I'm just going to come over here and I'll just copy this hack that I had over here in the inventory. So this processor, I'm just going to copy this over here. Just so we no longer have any errors. And I'm going to be adding that maybe somewhere around here. just like this, and the error is gone. Now, just to make sure that this doesn't also block anything for us, I think I'm also going to do the same. I'm just also going to cut this, and I'll just make this to be the last that we have over here, just to make sure we satisfy the process that needs to be async, just like this. And now we have the notifications processor. We are also going to register this in the notifications module. So here we're going to make this to be the notifications processor file, which is going to come from notifications.processor, and then we're going to give this file a save. Now we have done all of these, let's not forget that we also have the audit. So over here we still have the audit listener here, and this audit listener is still going to be calling, or you see over here, the event emitter 2, which for now is not emitting any event as we have just seen. So this is not also going to fire again until this gets migrated, just as we have migrated the notifications and also the inventory. Okay, I'm not going to be doing that in this step because this is just to go on and migrate the inventory and the notification. But if you're building this for real, you want to make sure that you close this gap the same way we are using this same pattern over here. You want to make sure you just go on and make use of this processor, just as we have done previously. And actually, this is a good challenge for you to migrate the audit listener to make sure the audit listener is also making use of the queue. Now I'm going to open up the terminal. We can see the terminal is up and running, and let's come over to BullMQ, and I'm just going to give this a refresh, and we still see that, hey, this is still here, and this is under waiting jobs or under latest jobs, other created, the progress, the options, the logs, the error, and this actually has completed over here. All right, so I'm going to just clean this, or maybe delete this here, and this has been removed so that we can start this from scratch. Now I'm going to come over here and open up the Thunder client again, and I'm going to come over to the orders so that we can create another order. I'm going to send this order here, and let's take a look at the logs. You can see now the logs are back. We have the order here which has been created, and you can see we are calling the notifications processor that is sending a confirmation email, and you can see the confirmation email is also queued for the notifications processor. But I do not see the other processor over here, which is the inventory processor. So let's just double check that this is still working as expected. In the module, we have the inventory processor here, and if we come over here, we should also see the log here, but we do not see this log. Okay, so no worries about that. Let's come over to BullMQ, and let's give BullMQ a refresh, and you can see now, we can see here we have this, failing, completed, it's not active, and here we are not seeing the, we see the notification, but we are not seeing the inventory process over here. This is an architectural bug over here, so we are going to be fixing this over here because BullMQ queues are competing consumers, so it's not a publish and a subscription. And when multiple processor classes are going to point to the same queue name, in this case order event, they don't each get a copy of every job. Now what's currently happening in our application is that they are competing for jobs, and each job is going to go to whatever worker goes on to grab it first. That's why we are currently seeing only the notifications processor fire. It's happened to win the race for the job, and the inventory processor is never going to get a ton. We are going to make sure that we fix this bug next, and this bug is going to trickle down to some of the files that we have already worked on previously. And once this bug is fixed, then we can continue. Then we can go into continue. So let's fix this bug that we just noticed next. Let's fix this bug that we noticed. So we're going to have one queue per independent consumer, because as we just noticed now, BullMQ queues are actually competing consumers, so not a publish and subscribe. So we're going to have a single shared queue with multiple processors, which would split the jobs between them instead of delivering each job to every processor. So this is going to give each consumer its own queue, and this is what is going to reproduce the every listener reacting independently behavior that we had when we were making use of event emitter 2 previously. So how do we fix this bug? Now, as I said, it's going to be some little architectural change or maybe a major architectural change. And we're going to start from the queue constant. So let's have the different queues that we need here. And the constants, currently we just have the order events. Now we're going to change this. Rather than have the entire order events, we're going to have the specific queue name registered in here. So let's bring them in. We're going to bring in the inventory, which is going to be the inventory events. Then we're going to have the notification, which is going to be for notification events. And we're going to have payment further down the line. So this is going to point to payment events. Now we have this. I'm going to fix this linting here, but this is not all we need to do. Over here, we also need to go and export this constant, which I'm going to call all other queue names. And this is going to be the object.values, the queue names, just like this. All right, so now let's go and give this file a save. This is one change. Now the next change is going to be right inside the queues module. You can see we already have errors here. So we're going to have this register queue and we're going to pass multiple objects here. So right here, we're going to have the first one here, which we can pass in the name. And the name here is going to be the queues name dot, let's say, inventory. And I'm going to bring this down 2 more times because we have for the notifications and we also have for the payments. So here I'm going to swap this out with notifications. And the last one, I am also going to update this to point to payments. Now let's go and fix the linting errors. And now we also have this error over here. Now the fix is the same. We're also going to individually pass this object where we're going to pass in the name. But the name is not going to be the queue name dot, let's say, order events like this. This is going to be queue name dot inventory like this. And now the adapter is going to be the BullMQ adapter. So let's bring this down 2 more times so we can have the same for the notifications and also for the payment. So this just needs to change to notifications and this just needs to change to payments, and we need to fix the linting error that we have here. Now we're going to give this a save and let's also double check the application module is okay over here. So the application module is okay. We do not need to make any changes to the application module. Now this is one bug we have fixed. Now we're going to continue and we're going to go over to, I'm just going to close all these tabs that we do have open. And we are also going to, let's have a check at the orders module. So over here, the order module is okay, but we need to make a change in the orders service. As you can see, we already have errors here where we're going to inject the queue. So we're going to be changing how things works over here. Now we're going to start by having a job option here. So here we're going to have a constant and I'm going to bring in this constant here, which is job options. And these job options is going to have the attempts, which is going to be 3. We're also going to have backup. Backup is going to be of type exponential as constant. And the delay is going to be 2000 milliseconds. The remove on complete is going to be equals to 100 and remove on fail is going to be equals to false. Now this is going to mean we are going to have a change in the way the construction or the constructor currently works. Now I'm going to leave this here so that we can see the difference. The change is just going to be a little bit minor here. So we're still going to inject queue, but we need to inject the inventory, the notifications, as well as the payment. So I'm just going to comment this out temporarily. And here I'm going to bring in the new look constructor that we have. So in this constructor, we are going to have the inject queue, which is going to take the queue names.inventory. And we're going to have private read only the inventory queue, which is going to be of type queue. And we just need to do the same for the notifications. And we also need to do the same for payment. So this is queue names.notifications, private read only notifications queue is going to be of type queue. And the last one is going to be the at inject queue for the queue names.payments, where we have the private read only payments queue, which is going to be of type queue just like this. And then we can go on to close up the constructor. I'm just going to quickly fix this lint that we have over here, and I'm just going to get rid of this constructor that we had previously, and then we can give this file a save. Now let's go on to make a change here. So as you can see, this is what we were doing previously. We were adding to queue and all of this. This is going to change. So I'm going to get rid of this, and what we are going to do next, we are going to have the event, and this event is going to be equals to a new order created event like this. So we know that this needs the ID. So the order ID, it also needs the user ID. It needs the order items and the order total. Now we're going to have this promise.all, which I'm going to explain what this promise.all is doing. So we're going to await promise.all, and we're going to add to the inventory like this. We're going to say this.inventory queue.add. So we want to add the order events.created, and then the event and also the job options like this. Then we're going to do the same for the notifications queue. So we'll call .add where we add the order events.created. We're going to pass in the event as well as the job options. And lastly, we are going to be doing the same for the payments queue. So we'll call the payments queue.add. We want to add the order events.created. We pass in the event and we pass in the job options. What we are doing over here by having this promise.all is actually finding out the same event, but this time around is doing this to every independent consumer. As we can see, the order events.created, but this time around we see it's been added to the consumer, which is the inventory queue, the notifications queue, as well as the payments queue. So let me fix this linting that we have over here, and we no longer have any errors in this file, and we can give this file a save. And actually, this is enough for what we needed to change over here. The only thing I'm going to double check right now, as we have the order service done, I'm just going to double check here where we have the processor. So the inventory processor that we created previously. Yes, we have an error over here. Now this is no longer going to be the queuenames.order events. This is going to be the queuenames.inventory like this. Now this queue name here, inventory, is going to get the event, because right now if we check over here in the orders service, we can see the orders service is currently adding to the inventory queue, and it's adding this same event to the inventory queue, and it's doing the same to the notifications queue, and it's doing the same to the payments queue, which we do not have at this point. All right, so you can see this is the flow, and this is how everything goes on to work. Now that's the only change we needed to make in the inventory queue, so everything else can remain the same. We are going to be updating the same in the notifications queue. So let's come over to the notifications queue, and here in notifications processor, sorry, not queue, this is going to be the queue names dot notifications like this, and now we can also give this a save. This also is the only change that we needed to do here, and as I said previously, if you want to go on and migrate the audit, you can also go on and migrate the audit, and everything is going to work as expected. Now we're going to go on and double check that everything is working as expected. So let's open up our terminal window here, and I'm also going to go on and create the new event. So let's come over here to the internal client. I'm going to come over to orders, and I'm going to send across this order again. And here you can see now we have all our logs. We have the logs from the order service. We also have the logs from the inventory processor. As you can see, the 2 logs over here. We also actually 3 logs over here. We can see here that is complete. And then we also get the log from the notifications processor. Let's come over to our browser. Over here in the browser, queues not found, but we can see over here we have the different queues. So let's come back to the dashboard. We can see in the dashboard we have the inventory queues, which has 1 job. We can see the payments notification event, and you can see this has been completed, but this is still in the waiting queue because we do not have the payment event yet, or the payment processor yet. So let's go into the inventory event. You can click here or you can click here, and here you can see the data here. You can see this has been completed because this consumer has finished processing this specific event, and that's why we can see over here this inventory can go on to have these logs. Same for the notifications, and you can see it just has 1 attempt. So just one attempt over here. You can check the progress, the options. These are some options that we can pass. So it doesn't mean that this is what happened. You can see this was in 60 milliseconds. Over here, no logs, no errors, and you can see this is the actual data. And you can see this has been completed. We have the notification events as well, which also has been completed. You can see everything here, but the payments event is still waiting because currently we do not have the consumer created for the payments event. Now you can see that both processors are live and actually reacting independently, making use of their own queues. Now we're going to prove the actual point of this migration by going on to kill the application mid-job, and let's go on to watch it actually recover. That is what we are going to be doing next. Okay everyone, so what we're going to do now, BullMQ already knows how to detect a worker that stopped mid-job, and this is called the stalled job, and by default BullMQ is going to wait 30 seconds before deciding a jobs worker has gone silent and then going on to requeue it. Now what's going to happen, I'm going to actually reduce that 30 seconds to 5 seconds so that we do not sit on camera for 30 seconds. And what's going to happen is I'm going to try to give it a 15 seconds delay. So, and within that 15 seconds, I'm actually going to kill the terminal just so that we can see what happens. Okay. Let's see how this works. We're going to come over here and I'm going to be using the event tree for this. So the event tree processor, let's come over here, and in this processor, here where we have the processor and we register the name like this, we can also go on to have these options. As you can see, we can have the options. And this is the stalled interval. We can pass in the stalled interval. As I said, I'm going to pass 5 seconds here rather than 30 seconds, and the maximum stall count, I'm just going to also pass this to 2. So this is how many times a job may be marked as stalled, and then it can goes on to be requeued over here. Now this isn't just going to fix everything. We need to also go on and simulate a delay. So what I'm going to happen is maybe somewhere after here, before I go on to do the actual job. So here I'm going to see this here, and then we are going to have a window where we can stop this. So we're going to await a new promise like this, and this new promise, I'm going to just come here and have the resolve. Nope, this is going to take in the resolve and the reject, as you can see over here. So here I'm going to call the resolve, and I'm going to not call resolve, I'm going to just call set timeout, and inside set timeout, then I'm going to call the resolve, and I'm going to pass the time or the delay. I'm just going to say 15 seconds like this, 15,000 milliseconds. Now I'm going to give this a save. We are not going to see anything here because this is going to be triggered or always triggered whenever we create an order. So let's try to create one order here. I'm going to give this a send, and you're going to see the notifications provider, and I'm currently waiting for the inventory provider, as you can see here, and then I'm going to quickly stop this. So we saw the inventory provider processor actually instantly, but then it was in that delay. The notifications provider is complete, or the processor. If we come over to BullMQ, yeah, this is not going to load, right? Because I did quit the dev server. So now let's start it back up. I'm going to start up the server, and let's see what happens to the inventory processor that we were currently working on. Okay, so I'm just going to give this just for us to see that the crash actually survived, or the job survived a crash that happened. So you can see over here the reserving stock for this order. Here we see 1 attempt, and it's also going to go back, and you can see it reserved this and the stock reservation complete. How is this possible? That's because BullMQ had this in the queue. So you can see over here we have these 2 waiting. Okay, actually this is for payments, but if we come over to the inventory events, we have the 2 that was completed. So this initially was moved to this initially over here was moved, and then it got completed. So I don't know if we can monitor this somewhere here, but we can monitor it, but we can see that it actually got in the stalled job, and then it was requeued. And when your server came, or when your server comes back up and running, you can see it went on to complete that specific stock reservation. This just goes on to show that the job actually survived the crash clean it this time, but something actually happened. The job ran again and it raises an uncomfortable question. What happens when that retried job is a payment? So let's go and build the payment and find out what happened, because yes, the job actually went on to, run again. But if it's a payment, then what goes on to happen to your payment? As I said, let's go on and build payments next and find out. We are moving over to the payment service. Okay, so let's create that. I'm going to close all that we do have here. And let's come over to payments. Do we have payments? Yes, we do. Let's get rid of the git keep that we had from previous. And right here, we're going to be creating the payment hyphen gateway. And this is going to be .service.ts file. In here, we're going to bring in the imports. Let's import injectable and also logger from NestJS common. And after this, we are going to be having to import random UUID from crypto. Let's go on and have this interface for the charge record. We're exporting the interface charge record, which is this object. So the transaction ID, which is of type string. We're also going to have the order ID, which also is of type string. Then we're going to have the amount. The amount is of type number. And lastly, we are going to have the charged at, which is going to be of type date. We are going to mark the class as injectable and go on to export the class the payment gateway service. And over here, we're going to have the private read-only logger, which is going to be equal to the new logger, making use of this payment gateway service name. Now we're also going to have the charges, which is also going to be in-memory ledger that is standing in for a real provider's transaction history, something you're going to have with Stripe, but we're going to keep this simple on purpose. Okay. Now let's have this charge method, which is going to take in the order ID of type string, also the amount of type number, and it's going to return a charge record promise. In here, we're going to have the record, which is of type the charge record. So let's build the record here with the transaction ID, which we're going to call random ID. We're also going to have the order ID, and then we're going to have the amount. Remember, all these are coming in from this function, and the charged at is going to be a new date. Then we want to push this new record into the charges list. So we're going to say this is charges.push record like this. And then we can go on to write a log to the console. So this logger.log, we're going to say charge this specific amount we call to fixed to for this specific order, where we're going to inject the order ID and the transaction, which we're going to get from the record transaction ID. Then we are going to go on to return the order. The last two we are going to have is for find charges that belong to a specific order. This is going to take in that specific order ID and it's going to return a charge record list. Then in here, we're going to return this.charges.filter, where we're going to get each charge and we're going to return where the charge.order ID is equals to the order ID. Then the last one is to find all the charges. So we're going to get the list of charge record and just return this dot charges call just like this. And then we can go on to close up the charge or the payment gateway class. So I'm going to make sure I fix this here and get rid of the async because we do not have any await over here. So why do we have this record? This is because, or why do we have the error? That's because here we were expecting a promise, and I'm going to save this file. So I want us to take a look at this charge over here. What are we doing with this charge? Now, this charge is going to simulate a real call to a payment provider. And every call that is going or that is happening here is representing real money that's actually going to move in a real application. But you should go on to know that this method does not do, or what this method does not do, like it doesn't go on to check whether this order has already been charged. This is not going to do that. It's not checking if this order has already been charged. That gap is exactly what this step is going to expose and what we are going to be closing in the next video. Okay. So after this, we are going to be creating a payment processor file, so the payment processor, just as we do have for the notifications and orders. So here, let's create the payments.processor.ts file. And I'm just going to collapse this. I'm going to start by importing processor and also worker host, which will come from NestJS BullMQ. And we also need to import logger. Let's import logger from at nestjs/common. Then we're going to be importing the job. So we import job from BullMQ. And then we're going to be importing other created event. The other created event is going to be coming in from the orders folder. And then we have the events, and then we have the other created event. Next, we're going to be bringing in the other events. The other events will come from the orders, and then we have the events, and we have the other event constants. Then we have two more we need to bring in. First, the queue names. Let's import queue names from, and this is going to go to the queues folder, and then we're going to bring this in from the queue constant. And lastly, we need to bring in the payment gateway service, which is coming from the file that we just created. All right, so now we have this. We are going to mark the class as processor, just as we have done, but this is going to be the queuenames.payments, and we can go on to export the class, the payment processor, and it's going to be extending worker host. Now in here, we're going to have our logger instantiated. So private read-only logger is equals to a new logger, and we're going to pass in the payment processor.name. And also in the constructor, we are going to inject the payment gateway. So here in the constructor, we'll say private read-only payment gateway is of type the payment gateway service. And in the constructor, we are going to call super. Now we close the constructor, and let's have the async process, which is going to take the job and is the other created event, the return of void, and is going to the type name is the string. And this is going to return the promise that resolves the void. And we're going to just have a quick check over here. We're going to check if the name doesn't match the other events.created. We just want to return. Let's have the event. The event is equals to job.data. And we're going to call this.logger.log. And here we're just going to assume we are actually going to process, or we are processing payment for an order. And we want to also output the event.order_id, and as well as the number of attempts. The next thing we are going to do, we are going to then go on to call the payment gateway so that we can call the charge. So remember, this is event-driven architecture. So we are going to call the charge method that exists on the payment gateway service and pass the order ID and the total. Now after this, we are going to just check if the job attempts made is equals to 0. Then we're going to throw a new error because this failed to persist the payment confirmation after there was a charge. But if then we are not throwing this error, that means everything was fine and good. And what we are going to do then is to just log that payment has been confirmed for that specific order. So if we do not fall into the if block, we're just going to call the logger.log, and we're going to log payments confirmed for this specific order here like this. All right, so you can see over here, why do we have this error? That's because this isn't a sync. Unexpected is of await. Yeah, this isn't a sync. So once we get rid of the awaits, we are going to have an error over here. And I'm just going to copy what we did over here where we returned null, just to make sure we no longer have the error. So I'll just copy this, and I'm going to just put this maybe somewhere here just to have an async call here. So let's see what's going on. Why do we have this job attempts equals to 0 here? This over here simulates a realistic ugly failure mode. Okay, now this mode over here is a situation where the charge succeeded against the payment provider. So maybe Stripe or whatever payment provider, the charge actually succeeded, but something after it. So maybe something like writing the confirmation, or let's say something like updating the order status, something after the payment went on to fail. Now, BullMQ is going to see this as a failed job, and then it's going to retry it using the step that we set up previously. So remember the retries attempt that we have previously. So BullMQ is going to retry this. But the charge that we do have above, so the charge that we have over here has no concept of like we have already charged this order. And the retry is going to charge the customer again. We are going to be fixing this in the next video. So we're going to fix this once we make a charge. And this is what is called idempotency, okay? We have the job.attempts made here, which is equals to 0. Now this is used here just purely to make the failure to be deterministic and also to be repeatable for just this demonstration. But you never want to make sure that you have this in a real production logic just because of the steps that I just created, okay? So you can go on to treat this as temp code, just like this. I'm just going to leave this comment here, temp code, don't push to prod, okay? So then let's go on and save this. Now we're going to continue, and the next thing we're going to work on is the payments module. And once we have the payments module, we're going to register it right into the applications module. So over here, we are going to create the new file, and this file is going to be the payments.module.ts file. And then we can close this up. Okay, so this is going to be pretty much quick. We are just going to we're just going to be importing module from NestJS common. And then we need to bring in the payment gateway service because we need to have this in the provider. So let's import the payment gateway service, which is going to be coming from the payment gateway service file. And we also need to make sure that we bring in the payment processor. So let's import payments processor, which is going to come from one level up the same folder, the payment processor file. We're going to have the @module decorator, and for the providers, we know we're going to have the payment gateway service and also the payments processor. And next, we are also going to have the exports. The exports is going to be the payment gateway service. And finally, we are going to be exporting the class, the payments module array, like this. Now we have the class. We need to make sure we register this class into the application module. So I'm going to save this, and let's come into the application module. And over here in application module, just after the audit module, which isn't doing anything in application as we have explained previously, we are going to have the payments module. So now we have the payments module. We are going to give this a save. So let's go on and test out what we have written. So over here, remember, we have this in payment processor, where we say if the job.attempt made is equals to 0, then we need to go on and throw this error. And once we throw this error, this charge is going to get called again. So this charge over here is going to get called again. Let's see this in action. So I'm going to open up the terminal, and you can see over here, so you can see we already have a charge over here. Now, the reason why we have all these charges here is because we had this. Remember, we had the payment that had the payment already had this in waiting. So it had some queues, but now it's there, it has been completed. So that's why we see this over here, okay? So now what's going to happen, I'm going to quit I'm just going to leave or maybe I quit the dev server and clear and run the start dev command so that we can see the logs new and fresh. Then I'm going to open up the Thunder client, and I will come back to the orders so that we can create a new order. I'm going to send off this order. So let's take a look at the terminal, okay? So let's take a look at the terminal. We're going to have approximately like 2-second exponential back off because we did set up in the config. So in case you're wondering, if we come over here and we check the orders and we check the orders service, so you would see over here, we set this. So we set the 2000 or the 2-second exponential back off, okay? And also the retry is going to be retry attempt. So let's go on to open this up and let's try to send the order. So we expect this to have that approximately 2-second delay. I'm going to send this, and now you see sending this payment. We can see sending confirmation email, and then we also see confirmation email queued, reserving stock, charge this for the order. And you can see here, this is the attempt 1. And you can see here, this also is the attempt 2. This is a problem because you see that a user is getting charged twice. The first time this logic is going to get called, where we have the payment processor, we see that this over here has a job attempt made of 0, and that's why it throws the error. And because it throws the error, BullMQ is going to retry it after a couple of seconds, approximately 2 seconds, based on this logic that we have over here. So BullMQ is going to call again, and when BullMQ calls it again, you can see now the attempt is equals to 2. And because this attempt is the attempt is equals to 1, the user gets charged from the previous one, and then it's going to get called the second time. And you can see we have 2 payment charges over here. So we are charging the user twice for the same payment just because something else failed. So this could be something else that failed. As I said earlier, maybe updating an orders logic, or maybe something logic here failed. And because the logic here failed, BullMQ added this back to the queue, and the user is getting billed twice for the same order. Now let's also double check BullMQ. And if you check the BullMQ, you can see, and here we have this completed, and this says nothing about the fact that the customer was actually charged twice. So before we had completed 2, but now we have completed 3, but it doesn't tell us the customer was charged twice. Now, we just watched the user that gets charged twice live in our application using our own retry configuration. Now we're going to fix that permanently, making use of idempotency. Let's see how we can have this right up in our own application. Now is the time we're actually going to fix the bug that we just saw over here. And I just want to make a little but very important architectural note or announcement here. But first, let me close all these tabs that we do have open. Now I'm going to be creating a separate raw Redis client, which is going to be the Redis module, instead of reusing BullMQ internal connection. And the reason is BullMQ goes on to manage its own Redis connection for queue mechanics, and for us reaching into those connections directly for application logic isn't something that the library is actually designed to support. So what's going to happen, we're going to be creating a small but dedicated client just for general purpose atomic commands like the one we're about to use over now. So let me collapse all of these that we do have open, and let's create the Redis client. We are going to start by first, we are going to be creating into the common folder, and we are going to be creating one for Redis here. And then we are going to be creating a Redis, we are going to be creating a file in here. This file is going to be the redis.constants.ts file. Now here we're going to export this symbol. So this token Redis client is going to be equals to the symbol Redis client like this. And now we are going to create the Redis module. So let's save this file, and in here we are going to be creating the redis.module.ts file. Alright, and this is going to bring in the different imports. First, we're going to be importing global and also module decorator, which will come from NestJS common. And we are also going to import the configuration module as well as the configuration service from nestjs/config. So remember earlier we installed IO Redis. Now we're going to import Redis, which is going to be coming from IO Redis, and then we're going to be importing the Redis client. Now this Redis client is what we just registered in the Redis constant, so we're going to be importing it here. Next, let's have at global and also at module decorator, so we can mark the imports to register the config module. And in the providers array, we're going to have this object here, or this class here, where we provide the Redis client, and we want to inject the config service. Because we are injecting the config service here in the use factory function, we are going to have the argument config, so the config service type here, but we stored it as config. And here we're going to just return a new Redis client with this configuration. We're going to set the host to this config.get string here, where we're going to get the Redis host from the config or default to local host. And the port is actually the same. We're also going to get this from the config, so our environment variable, just like this. Now let's go on and close up everything we have here. And I'm going to be exporting the Redis client like this. And I'm also going to cover this up and export the class Redis module. This over here is the Redis client, and as you can see, I went on to mark this as global. And the reason why I mark this as global is so that any module can go on to inject the Redis client without having to import this module everywhere. So it needs to only be imported once here and in the root of the application. Now what we have here is a raw IO Redis client that is going to be separate from the BullMQ internal Redis connection. Just as I said earlier, that BullMQ goes on to manage its own connection for queue operations, and using those connections for direct or application level logic like idempotency keys isn't just a supported pattern. So this over here, what we have over here, just a small dedicated client that we're going to use for exactly that. So atomic general purpose Redis command that is outside of the job processing itself. Now we're going to be creating the service right in here, but it's not going to be into Redis. This is going to be right into payments, where we do have the bulk currently. We're going to create an idempotency service. So here, let's have this here, idempotency.service.ts. I'm going to collapse this, and I'm going to bring everything we need, starting with the imports. I'm going to be importing inject and also injectable, as well as logger, which would all come from NestJS common. We also need to go on and import Redis from IO Redis. And then we're going to also bring in the Redis client. The Redis client is going to come in from the common Redis and the Redis constant file that we created not quite long. And the idempotency service is going to be marked as injectable. And here we can go on to export the class, the idempotency service class, and we can have the private read-only logger, which is going to be equals to new logger idempotency service.name. And then in the constructor, we are going to inject the Redis client, and we are going to have private read-only Redis, and this is going to be equals to Redis. So we are injecting, and the token is going to be the Redis client here. Let's go and have this async reserve. This is going to take in the key, the TTL sequence of type number, and it's going to return a boolean. That is a promise that results to a boolean. So const result is going to be equals to await this.redis.set. We are going to give it the key, we are going to give it the value, the expiry, the time to live seconds, and the not expiry time here. And here we're going to return result equals to the string of OK. So this is the check is going to do over here. Then we're also going to have the async release key here that's going to return a promise that resolves to void. And we're going to go on to await this.redis.delete, where we pass in the key. Finally, we can go on to have our log. So we call the logger.debug, and then we're going to say release idempotency key, and we're also going to have the key over here. Okay, so now we have this. The next thing we're going to do is to go on and edit the current payment processor file that we have. And not before I go on to fix the linting errors that I have in this file here. I'm going to then give this a save. And let's come over here. And if we come into the payments processor here, we are going to be making some changes here. So we're going to have the payment idempotency TTL sequence, which we're going to be registering just here. So I'm going to bring it in. The payment idempotency TTL sequence is going to be equals to the 60 times 60 times 24, which is going to be equals to 24 hours. So now let's make use of this right here, where we only have the payments gateway. This isn't going to be enough. So I'm just going to bring this down like this and also bring it down again. And I'm just going to duplicate this. But now this is not going to be the payments gateway. This is going to be idempotency service And this is going to be of the type the idempotency service, which is going to be imported from the idempotency service here. Now inside the process, because this is extending worker host here, so right inside the process, we're already checking the jobs.created if the name doesn't match, and then we get the event. As you can see, this is the other created event that we get in the job data. Then we're going to have the log, but before we have the log, we want to have the idempotency key for this specific transaction that is going on, so that we can go on to have an idea or have this in Redis. So just somewhere here after the log here, before we go on to call the charge, we want to make sure that or maybe we even call this before the log, but let's have it here first. The idempotency key is going to be equals to payment and then the order ID. I'm actually going to move this right up here so that it comes before we start going on to do some processing here. So now we have the logger. This is very much okay. But we're going to do something. We want to know if this is a new reservation. How can we know if this is a new reservation? So there's one way we can know if this is a new reservation, and that way of finding out is by calling the reserve. Because if we check the idempotency service here, so this service, you will see here we have this reserve. This goes on to, check because it returns a boolean here. So over here, we are going to check if this is going to return true or false. So we're going to say const is new reservation is going to be equals to await this dot idempotency service, and we're going to call dot reserve where we're going to pass the key, and we're also going to pass the TTL seconds. So this is the payment idempotency TTL seconds, and if this is not a new reservation, here we are going to just have a log, and this log is going to say this.logger.warn, and we're going to warn the order with this event.order ID is already reserved. So we say this has a reserved / completed payment. So we want to go on and skip duplicate charge here, and we're going to just add the attempt here in the log as well. Then we want to make sure we go on and return. But if this is not a reserve or a new reservation, so a new payment, we are then going to go on and just have the logs here. So I'm just going to close this, and we're going to call this .logger.log that the idempotency key has already been reserved for this. So this set is not going to go on and create duplicates, okay? That's why at this point, if it's not there, we are going to go on and create a reserve for this specific order, and then it's going to proceed to charging the user. So let me quickly fix this that we have here and give this a file a say, but this isn't everything that we need to do. What's going to happen is, as we see here, we are calling the charge. So I'm just going to cut this because now we're going to have this in a try catch block, because what happens when payment fails? We want to go on and also release this key, because if payment or if charging fails, and at this point we go on to reserve this key, the next time the user comes here, we are going to hit this block and return hereby charge failed. So this is why we are going to cut this, and we're going to wrap this in a try catch block. And you can see over here automatically, or maybe I don't know what happened, to be honest, or maybe automatically this was immediately put inside here. And now what we're going to do next in the chat or in the catch block, we are going to await this and call the idempotency service, and we're going to call release and want to release the key. So we no longer want to have this in Redis. So the key over here is equals to this idempotency key that was created here. So this key here. So we're going to take this key and we're going to pass the key over here and close this up like this. Now, since we do not do anything with the error, we can also get rid of the error object over there. Now we still have this here, which is going to still go on and stimulate a failure after a successful charge. But no worries, we are still going to leave this here as we are going to, or as we are still in testing mode. To make sure that we lock everything up, let's come into the payments module, because now we have the idempotency service. So let's come into the payments module, And here we want to make sure that we also register the idempotency service right in here, and we give this a save. Now we have our Redis module. We also have not registered that in the application module. So maybe we can do that somewhere around here. Maybe somewhere around the event emitter, we can just have the Redis module here. So I try to keep all this more or less like configuration, third-party stuff here. And our core application, I just try to keep them here at the bottom, okay? And then we're going to give this file a save. We are going to test this again. So this was the behavior we had previously. Now it is gone, but do you remember the behavior we had previously? Let's give this another trial. So I want to see if we are also going to have duplicate attempts for charging the user. So I'm going to close all these tabs we do have open up the Thunder client so that we can give this another trial. So we see here that it's reserving stock for this order here, 1 attempt, just like this. And that was because this was more or less like pending, okay? So I'm just going to change something here real quick. And we see that because we have the 15 seconds wait, we see that it has reserved and this has been completed for this order. So no worries, this is just it's not really the payment. This is because we have that waiting time of 15 seconds. And here we have the product ID. I'm just going to change this here just so that we can mix things up, and also just change this here a little. So let's give this on that trial. I'm going to hit send here. So let's see. And I'm just going to go and cancel this. And we see that this payment here already has a reserved completed payment. It's skipping duplicate. And we can see confirmation email has been queued, processing payment for this order, idempotency key reserved for this order. So we see the idempotency key has been reserved for this order here because this was generated a random order. And we see processing to charge, and we can see it's charged $30 because we had 5 items here for this order transaction. And because we broke our application, because of this logic we have here, if we come over to the order service, because of this that we are doing here, where we're going to throw, actually not the order service, the payments here. So let's come over to the payments, and because of this payment processor here where we're going to fail this, that's why over here we see that the first time it failed, we see that the idempotency key has been reserved. So this is coming from our Redis module, our Redis service, and then we see that it went on to charge the user, processing payment, and the attempt is the second attempt. So the first attempt here was this attempt over here, and this was the attempt where it went on to reserve and it charged the user. Now it went on to process payments because of the error. So after we have the charge, it went on to fail over here because you see this is breaking, and because we charged the user beforehand. So here where we have our try catch block, where do we have our try catch block? Over here. So we go to charge the user, that works fine, and then we come over here, we fail. So the first time it sees that we are processing payment, and then we also see the key has been reserved here, and then we go on to charge the user. After charging the user, we fail in BullMQ level, and BullMQ is going to call this again, and the second time it calls, we see we are processing that same order here, but then you see we get a warning because this order already has a reserved completed payment, and you can see now we are skipping duplicate charge. This is excellent and this is wonderful. Let's bring up our application up and running because we also have the inventory which then needs to run because currently that is in queue state in BullMQ. So now we're going to see the reserving stock for this order, and after a couple of seconds we're going to see that this order has been completed. A legitimate charge failure now goes on to correctly release and also retry, but jobs that exhaust every retry still need somewhere to actually go on and land instead of vanishing. Let's build the dead letter queue next, and you're actually going to understand what we mean by this dead letter queue.